So it's nearly Christmas, so I decided why don't I do a more informal episode where I just try and hack together some kind of snowy effects in HTML canvas. So I haven't planned anything out for this video, and I'm just kind of going to wing it, and I'm going to need to look things up and build it as I go. So this is going to be more of an insight into my normal everyday kind of workflow, the way that I work through problems. I'm not going to hide any of the tools that I use or any of the workflow that I usually go through. It's just basically going to be you watching me trying to solve a problem like I would every other day. So in front of you, we can see the terminal. So let's just create a directory and get right into the code. Make a directory, I'll call it snow, I'll cd into snow. Then a tool that I usually use is tmux. So we'll open up tmux, and what tmux is a terminal multiplexer. So it allows me to create multiple instances of a terminal within one window. So what I usually do is split up my window like this, which is a bit weird now that the font is this big, but we'll deal with it. So I'll just create an index.html and we'll create an index.js. So we'll open up the index.html and we'll just give it a script tag and we'll give it index.js. Close that off. Let it snow. What we'll call it there. Open up this console log. It is working. It's just a sanity check that I like to do. And then down in this terminal, we will run live server. And then we've got a browser window open here. We can open it up. It is working. Okay, so we've got the sanity check. So now we can start building some stuff. Okay, so I'll maximize that Vim again. And I'll just start out. We'll create a class and I'll call it Christmas. Why not? Give it a constructor. And what this Christmas class is going to be is kind of going to be a wrapper for everything. It's going to have our canvas in there, and then within our canvas we'll have snowflakes, and then I'll probably add in like some sliders to maybe add some gravity or some wind or something like that to the snowflakes, just to add a bit more dynamic nature to whatever we're building. But we'll see how much time we've got, and we'll see if we build that. So I'll just new Christmas. Good. And in the constructor, suppose I'm going to need a canvas. So this.canvas document.create element. Give me a canvas, please. And we'll need a context. This.context equals this.canvas.get context. I'd like a 2D context. Okay, so at this point, this is kind of the boilerplate, and then we'll just document.append child this.canvas, just so that it's in there and we have access to it. And I suppose I'll say this.canvas.width equals, I don't know, 800 pixels. This.canvas.height equals 800 pixels. Why not? Let's make it a square. So at this point we should have something if we look in the browser. Append child, only one element on document is allowed. Okay. Document.body.append child. So no errors, so that is a good sign. And here we go, we have a canvas, 800 by 800, good. So I think I'll just add a style tag here just so that we can put some style to it. I'll say body margin 0, padding 0, and canvas background say 231 F20. That's just the Hunger Turtle code, dark color thing. We'll take a look. So we have a nice dark canvas. Cool. So I'll close that. And then now what are we going to need to do? So we're going to want some snow. So I suppose we're going to need a class for a snowflake, I suppose. So I think what I'll do is create a vector class, and then that vector class will be used in a snowflake class. And then I'll use the vector class to manipulate the acceleration and velocity and position of a snowflake. And I think doing it that way is easier, because then in the vector class we can build in some methods that allow for like adding together vectors and multiplying them and that sort of thing. And it won't be a complete vector class. It won't have all possible methods that a vector could have, but I think having a basic version of that is going to make building out the rest of the snowflakes a bit easier, especially if we're going to start adding in like wind and gravity and stuff. Simulating that kind of thing is going to be much easier if we can have vectors, because then it's just vector maths to do that sort of stuff. Gravity or wind would just be a force vector, and then we can apply that force vector to the snowflake, which manipulates the snowflake's position, acceleration, and velocity vectors, and just kind of all makes sense. And I mean, this is something that you'll kind of get if you've done any game programming. If you haven't, this might be completely weird to you. Maybe you've got a traditional engineering background in vectors or something, or mathematics, I suppose. Hopefully, as we go through this, you'll kind of understand what I mean. So we'll just start building that. So I'll say class vector constructor. And then what are we going to do? Are we going to pass in the x and y here? I suppose we'll put in there. This dot x equals x. This dot y equals y. We'll give it an add. That takes a value. This dot x plus equals val. This dot y plus equals val. So that'll just be some basic stuff there. I'll probably need to add more into that, but we'll just keep going for now. Give a snowflake constructor, and then this is going to have a position. It's going to have a velocity. It's going to have an acceleration. Okay, we'll set acceleration to 0. We'll set this to 0 for now. I think what we're gonna do is randomize that initially, probably. We'll see, and then we want this to be a random position as well. Okay, what we'll do is we'll do vector dot random. So vector will have a static random, and this will return a new vector, and we'll give it a random. Okay, so we want min x max x min y max y, and then we want to so we want a random number between. So do I want to make that another method? Random num between min max, return min plus math dot random times max minus min. And then here I'll say random num between. Where do I pass in x first? I do min x and max x. And random num between min y max y. So that'll return a new vector that has a random x and y. And then we will use that random here to get a random position. And then we want to give that an x and a y. So random position between x and y, I suppose. Or width and height. So we want to give it a random. Oh, no, it's going to be 0. Between 0 and width and 0 and height. So that takes 4, right? Min, x, min, yeah. Okay. So that's that. And then probably make a random velocity too. So vector.random, and we'll say a random velocity between 0.1 and say 1. I don't know what these values are, I'm just kind of making them up. And we don't want much y movements. So we'll say between minus 0.3 and positive 0.3. Again, got no idea if these are the right values, but just kind of making it up. But we can always go back and tweak them if we need to. Then, so what we're going to do here, we've kind of got a snowflake. So I think we're going to need an update method on Christmas. So this is going to kind of be like a draw loop or a game loop. And what we're going to want to do here is draw all of our snowflakes. We don't have any snowflakes right now, so we'll have to do that. But then what we'll need to do at the end of the update is call the update again. So to do that, we'll use request animation frame, and we'll give it this.update. But then the problem here is that this.update is this, but this will have a different context when we call it because it's being called by request animation frame. So this is where it's kind of a weird JavaScripty thing. So what I'm actually going to do just to make it easy, so we could use bind here, but I'm just going to pass this an arrow function, and that just kind of cleans it up a little. We don't have to worry about binding or any weird things going on there. So we're going to need a setup, and here we will create all of our snowflakes. So how many snowflakes do we want? So const numFlakes equals, I don't know, we'll say 500. And then we'll need a this.snowflakes equals an array. And then this.snowflakes.append new snowlake. New snowflake. And then what do we need to pass into said snowflake? The width and the height of the canvas. So into that we'll pass this.canvas.width and this.canvas.height. Okay. So now we should have a whole bunch of snowflakes. So we want to call this dot setup here. And just after all of this, I'll just console log out this dot snowflakes, just to see that it's all working, because we haven't tested it in a while and code usually breaks. So reference error, random number between is not defined. Of course it's not. Yeah, of course. So I've put it on the vector class, but I should probably make this static. And I really don't like having it here in the vector class. Just kind of makes my skin crawl a little. But we'll just keep it there for now. And I'll say vector dot. Yeah, so sometimes, like, I find I'm very guilty of this, that in situations like this, I'll try and over-engineer a really elegant solution of the way to structure this and where to put the random num between. Maybe I'll make like a utils like class or something like that, and that just takes a whole lot of time, and you end up spending 90% of your development time just crafting some unnecessary abstraction just to make things look pretty, and you feel kind of good about it, but sometimes there is a time and a place for hacky code that isn't ideal, and I think this is one of those. So we'll do this. We'll save. This.snowflakes.append is not a function. I'm in Python land. .push. We're not writing Python code. Okay, there we go. So we have 500 snowflakes. And we have an acceleration of 0, a random position vector, and a random velocity vector. So now I think the next thing to do is to actually plot all of these onto the canvas. See if we can do that. So the next thing to do now is to plot all of this onto the canvas. So in the snowflake, we'll add an update method. And we will... what will we do here? And here we just want to update the position based on the velocity. So we'll say this dot position, which is a vector, remember. So we can add this dot velocity. And that is why we made the vector class, because we can do things like this. It's really nice. And then I suppose we will update the velocity by this dot acceleration. And that reminds me, this should be a vector. This should be a vector 0, 0. That's what it needs. Yeah, it needs an X and a Y. Okay. So we're updating the position by the velocity, and we're updating the velocity by the acceleration. And one thing we're going to want to do here as well is check for wrap around, but we'll cover that in a second. So now we can update the position of our snowflake, but we're going to want to actually draw it. So let's remove that. And then in the update, we're going to want to go for let flake of this dot snowflakes. And then we're going to call flake.update. We're going to update that particular flake. So now we're going to want to draw it onto the screen. So we're going to want to draw it as a circle. So yeah, I'm going to have to look that up. This was the X position, so this is flake.position.x and flake.position.y. Radius. We haven't got a radius. Every flake. Okay, we'll just say that's 10 for now, and maybe we'll go back and add in a dynamic radius there, a random radius, but for now we'll just set it as that. So we need to do that, and we want to set the fill. So this is going to have to be this dot context dot fill style equals, make that white, and context.fill. So then one thing we haven't done is we haven't actually called the update method anywhere. So in the constructor, we'll just call it once with request animation frame this dot update, just so that it calls it once, and then once it gets called, we're calling it again recursively. So the loop will just continue for the life cycle of the app. So I think that's something. So invalid or oh, again, I'm in Python land. Python. Yes, okay. So, is it doing anything? We are seeing nothing. Ooh. That is not good. That's not what we want. So there's clearly an error in our vector. So when we're adding, oh, of course, this is a vector, so it's not adding that. That is a vector. Silly me. So this will be vector dot x vector dot y. So now if we refresh the page, okay, that we have numbers. That's a good sign. There we go. That's a thing. Okay, well, that's not what we wanted, but it's a step. For a start, they're way too big. So we will scale those down significantly. Give them a radius of 2. That is a better radius. So what's happening here is every frame it's moving along, and we're just drawing on top of what we already have. We're not clearing out the canvas every time. And the direction of all of the snow is also very wrong. But we'll deal with that. So one step at a time. So we're gonna wanna clear out the canvas. So we're gonna wanna clear the canvas every time. So this is clear rect. And there we go. So we've got some particles floating around, but they're not traveling in the direction I had expected. They're all going left to right for the most part, but I want them going top to bottom. So the first place we should look here is the velocity of the snowflakes, because obviously the velocity is what's affecting the direction and the motion of these particles. So we'll check the velocity. So that's here. So we're giving it a random velocity between these digits in the X and these in the Y. So there's the problem. It's got a positive velocity here, so we should really have in the X between these. So we swap these over really. So we want it to have a little deviation on the X, left and right, and only positive values falling, which was the issue we had. So we'll say this between those values. And now if we hop back in, now we have some snow that is falling. So that's pretty good. Probably want to speed it up slightly. So maybe the slowest ones are moving a bit too slow, I think. So we'll move that up to say 0.3. And that looks quite good there. Okay, I'm happy with that. So I think what we're going to need now is a bit of variation in the radius of these snowflakes. And also maybe a bit of transparency. So some alpha. And then we want to wrap around so the snow continues to fall. So if we come back to here. So we're going to want to use the rand function again. And this is where it's kind of gross that it's in the vector, but we will just deal with it. We'll say this dot radius equals vector dot random number between, and we'll say between 1 and, I don't know, let's say 6. See what that is. And then here, instead of this 2, we'll give it flake dot radius. Come back into the browser, and now we have a bit of variation. I think these 6s are probably a bit too big, so maybe variation, where are we, radius, maybe drop that down to 4, see what that looks like. Refresh it just to make sure. Yep, I think that's pretty good. I'm happy with that. So we'll just add in a bit of alpha now. So we'll add in some alpha. We'll say this dot alpha equals vector dot random num between, say 0.1 and 0.9. And then coming back down to the update, fill style, we probably want that as RGBA, 255 across the board. So we'll use a template literal, and we'll make this flake.alpha. Okay, now come back here, and we have some transparency. Beautiful. So now we want to wrap around so that we have a continuous ever falling amount of snow. So in the update here, so here for the wraparound, we're going to want to know what the boundary is, and the snowflake isn't aware of that. But I suppose we are passing it in here, the width and height. So we can say this dot boundary x equals width, this dot boundary y equals height, and then from here we will say this dot position dot x is greater than this dot boundary x, and this dot position dot x equals 0, and else if this dot position dot y is greater than this dot boundary y, this dot position dot y equals 0, and we can also go off the other x-axis, so we'll say else if this dot position dot x is less than 0, then this dot position dot x equals boundary x. So we can wrap around both x-axes, and if we hit the bottom, we'll wrap around to the top. So if we take a look at that in the browser, we have an error. Boundary x is not defined. Obviously not. This dot boundary x wouldn't be like us to type things wrong. But there we go. We have continuous snow wrapping around everywhere. So I think at this point the tutorial's probably gone on a little too long. So I think I'll just turn it over to you. I mean, we've got a pretty solid foundation here. We have vectors controlling the position, the velocity, and the acceleration. And right now we're just setting that randomly, and we're not actually ever dealing with acceleration. But what you could do here is like simulate wind or gravity or add mass or anything to these particles, and all you have to do is tinker with the vectors. So you can apply a force to any of these snowflakes by simply adding on some force to the acceleration, because if you know anything about physics, you know that F equals ma. So force equals mass times acceleration. So you could give each of these particles a mass, and when you apply a force, you then change the acceleration. So acceleration equals force divided by mass. You could have like a wind, which applies a force, and that force will be a vector with an x and a y, and that x and y is the force in those planes. And then you apply that force to the acceleration of each of these particles or snowflakes. Then during the update cycle, that acceleration gets applied to the velocity. The velocity then affects the position. So we have that framework laid out. I'm just not going to go into that, but if you want to, the code for this that I've just done is going to be on GitHub. The link will be in the description. So you can take that and tinker with it. Add the ability for a defined gravity, or maybe if you click on the left or the right of the canvas, it adds a force in that direction. Or maybe you want to figure out how to make the particles be attracted to the mouse, for example. That's an interesting one. We're kind of deviating away from snow at this point, but maybe you click and all the particles move towards the mouse. I mean, that's quite a tricky one, because you're going to have to figure out what the angle is from each of these particles to the mouse and then apply a force in that direction. So that's quite a tricky one. So if you want to try and figure that out, do that. And if you do any cool stuff with this, maybe you make the colors change or something, I don't know. Just leave a link in the comments or tweet me at the proof of stake, or I don't know, even open up an issue on the GitHub of this and just let me know, or leave a comment on the website. Any way of reaching me. There's many ways to reach me on the interwebs. So leave me a link. I'd love to see anything that you do with this. But yeah, if you like this kind of video where it's not really planned out and it's just kind of free form, me trying to figure things out, let me know that in the comments, because I quite like doing this. It's basically just filming my day, tinkering with things, so that's pretty cool. And of course, as always, if you liked the video, hit the subscribe button, hit the like button, bell for notifications, all of that good stuff. But until next time, stay hungry and keep coding.